in this section, we're going to talk about the arithmetic and the geometric sequence. So let's go ahead and look at some patterns, because patterns are going to be very important as we talk about these two different sequences. So what is a pattern? Well, it's something that is generated that you can continue over time. So if we look at this first pattern here, we have a heart, a star, a heart. What do you think would come next if we were to continue the pattern? You're probably thinking, well, a star, and then a heart, and then a star. So that we would have heart, star, star, heart, star, star, heart, star, and we would continue the pattern on. The next pattern, we would have square, square, circle, triangle, square, square, circle, triangle. Now, those are shapes. Now let's start to look at some numbers. We have 6, 8, 10, 12. You're probably thinking, well, each time it's going up by 2. So my next number might be 14, and then 16, and then 18. And it would go on and on. This is a pattern. Okay, now we're going the other direction. Now we have a 4, but then we have a -2. So if we, moving from 4 to -2, aren't we subtracting 6? Well, if we keep subtracting 6, it looks like the next number would be -20, and then -26, and then -32 to continue the pattern. Well, patterns in numbers are actually called certain things, and that's what we're going to talk about today. The first sequence of pattern numbers are going to be the arithmetic sequence. The arithmetic sequence is a number pattern that either increases or decreases by adding or subtracting a common difference. What's very important there is that idea of adding and subtracting. So I'm going to go ahead and circle that, adding and subtracting. Okay, so let's go ahead and look at the first example here. So if I say 3, 6, 9, 12, we can see that each time I'm going to be adding 3 to this pattern. Now, by adding 3 to each pattern, this is called a common difference. So over here it says, what's our common difference? Well, +3 is our common difference. And I can continue my pattern, 15, 18, 21. And when it asks for a rule, the rule for my arithmetic sequence always starts with a variable. I'm going to use the variable n. And I'm going to say n, and then I'm going to put my common difference next to it. So n +3. And that's my rule. So what that means is that any number that I put in for n, if I add 3 to it, it's going to give me the next number in this given pattern. Okay, now let's go ahead and look at another pattern. I have 28, and then I have 21. So it looks like it's going down by 7 each time. Therefore, my common difference this time is going to be -7. And I could keep going here. If I said 7 minus 7, that would give me a 0, then a -7, then a -14. My rule would be n minus 7. Okay, the next one, 2, 0, -2, -4. Each time I'm going down by 2. Going down by 2 gives me a common difference of -2. I can continue my pattern, -6, -8, -10. That would give me a rule of n minus 2. Okay, now 7, 11, 15, 19. Okay, it looks like each time adding 4. So if I add 4 to each one, it looks like that. So my common difference is going to be +4. And feel free to put a little plus sign in front of anything that's positive. You're more than welcome to do that. So if I continue my pattern, I'm going to get 23, 27, and 31. my rule is going to be n plus 4. Okay, let's keep going. Okay, this time it looks like I'm going to be subtracting 6 from each term. So my common difference is going to be negative 6. Remember, if you're going down, that means that your common difference is going to be a negative number. I can continue saying negative 30, negative 36, and negative 42. My rule is going to be n minus 6. And the last one here, 4 and then negative 1. It looks like that's going to be negative 5 each time. So that gives me a common difference of negative 5, which gives me negative 16 in my pattern, and then negative 21, and then negative 26. And my rule would be n minus 5. Now, this is the arithmetic sequence, meaning that you're adding or subtracting a number each time. And your rule is always going to be n plus something or n minus something. Okay, now I'm going to switch gears and we're going to talk about the geometric sequence. The geometric sequence works the same way, but this time there's a twist. A geometric sequence is a number pattern that either increases or decreases by multiplying or dividing. So no longer are we looking at numbers that are being added or subtracted. Whenever you multiply or divide by that certain number is called a common ratio. So with adding and subtracting, it was called a common difference, and now it's called a common ratio. So let's look at the first example. I have 2, 6, 18. So 2, if I multiply 2 times 3, that's going to give me the next number 6. And 6 times 3 is going to give me 18. Therefore, my common ratio is going to be positive 3. Okay, so if I continue my pattern here, 18 times 3 is going to give me 54. And feel free to use a calculator. These numbers start to get quite big at this point. And 486. Now my rule is going to be a little bit different here. It's no longer going to have addition or subtraction. We're going to have multiplication. So, if you remember, when we talk about multiplication, we always say multiplication is when you have a coefficient in front of a variable. So I'm going to say 3 times n. You don't need a dot there, and you don't need parentheses. 3n will be just fine. Okay, let's try another one. 3, 6, 12. This time I'm going to multiply by 2. I'm going to continue to multiply by 2. So therefore, my common ratio is going to be 2. Okay, so if I do that, my pattern will continue, and 12 times 2 is 24. 24 times 2 is going to give me 48. And 48 times 2 is going to give me 96. And my rule is going to be 2 times n. Okay. 1, 5, 25. This time I'm multiplying by 5. 1 times 5 is 5. 5 times 5 is 25. 25 times 5 is going to give me 125. 125 times 5 is going to give me 625. And 625 times 5 is 3,125. Now, my common ratio in this case was positive 5. And my rule is going to be 5 times n. Okay, so those were 3 examples of multiplying. So we're multiplying by a common number to give me the next number in my sequence. Now let's look at a little bit of a different one. I have 80, 20, 5, 1.25. Notice how my numbers are going down. But they're not going down at a constant rate that I'm adding, subtracting. I'm actually dividing. I'm dividing each number by 4. So I'm going to say divide by 4 each time. So because it's division, it's a common ratio. So if I were to continue my pattern here, I would end up getting down to, they're kind of big decimals here, I apologize, 0.3125, and I'm just dividing both of these by 4. And then I have 0.078125. And I can continue dividing this by 4. Notice how if they give me a decimal, I also want to continue it as decimals. Now, what's my common ratio? Now, because we're multiplying and dividing, this is how I want to represent it. I want to represent it like this. 1 divided by 4. Because I'm really multiplying it by 1/4. Multiplying by 1/4 is the same thing as dividing by 4. So this is how I want to represent my common ratio. Same idea. When I create my rule, I'm going to say 1/4 times n. That's the same thing as saying n divided by 4. You could also write it like this. That is perfectly fine. Okay, let's try another one of these. 2, -4, 8, and 16. Let's see if I can get rid of this. There we go. So this one's a little hard because I'm jumping from a positive to a negative to a positive to a negative. So I need to think about, well, what number is going to give me a negative? Well, it's going to be a -2. 2 times -2 is going to give me -4. -4 times -2 is going to give me 8. 8 times -2 is going to give me -16. So anytime you jump from a positive to a negative to a positive to a negative, that means that your common ratio is going to be a negative number. So in our case, it's going to be -2. So we could continue this pattern here and multiply by -2. So -16 times -2 is going to give me 32. Then -64. And then 128. My common ratio is going to be -2 times n. Now the last one on our page here, we notice we have a fraction. Let's see how fractions work out. 27, 9, 3, 1, 1/3. So we can see that each time we are dividing by 3. So each time we are continuing the pattern by dividing by 3. That gives me a common ratio of 1/3. So the question is, how do I take 1/3 and divide it by 3? Well, there's actually a kind of a cool little trick here. So I have 1/3. Whatever the number is on the top, I'm going to leave it as is. But now I'm going to take that number in the bottom and I'm going to multiply it by 3 to give me 1/9. And if I continue this pattern, you're going to see what happens here. If I take that 9 at the bottom and divide and multiply by 3, it's going to give me 27. And if I do it one more time, if I take that 27 at the bottom and multiply it by 3, it's going to give me 81. So a fraction stays as a fraction, just like a decimal. And then my rule is going to be 1/3 times n. Or you could write that as n/3. So now we've talked about arithmetic and geometric sequences. So let's go ahead and practice a couple of these. All right, my first one, 5, 10, 15. So it looks like in this one, I'm adding 5 each time. So when we're adding, it's an arithmetic sequence. So my common difference is going to be 5. So let's go ahead and fill in the blanks here. 20, 25, and 30. And because it's a common difference, this is going to be an arithmetic sequence. And my rule is going to be n plus 5. Okay, 5, 10, 20. A little bit different than the first one. It looks like this one is going to be times 2. 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. And then 40 times 2 is 80. And then 80 times 2 is 160. Because I'm multiplying by a common ratio, this is going to be a geometric sequence, which would give me 2n as my rule. All right, 32, 16, 8. It looks like each one I'm dividing by 2. So 32, 16, 8. If I divide it by 8 into 2, it'd be 4. 4 divided by 2 is, here, I'm going to write it up here actually, divided by 2 gives me 2. 2 divided by 2 gives me 1. So this is a geometric sequence since I'm dividing. And my rule is going to be, remember, it's not going to be a 2 because we're dividing. It's going to be dividing as 1/2 n. We're dividing by 2, or you can also write that as n over 2. Either way is fine. Okay, next one, 12, 6, 3. All right, looks like we are dividing by 2 again. And we can keep this process going. If we divide 3 divided by 2, that's going to give me 3/2 this time. And now this is where the very interesting thing comes into play here. Watch this. So I'm dividing by 2. So my numerator is going to stay the same throughout. But my denominator is going to multiply by whatever that ratio is. So 2 is going to multiply by 2, which is going to give me 4. And 4 times 2 is going to give me 8. Kind of cool. This is a geometric sequence. My rule is going to be 1/2 n, or again, you could write it as n over 2. Okay, my next one, 8, 4, 2. Again, this is a divided by 2, 1. So I'm going to end up with 2 divided by 2 is 1. 1 divided by 2 is, well, that's 1/2. And then 1/2 divided by 2 is going to give me 1/4. That's a geometric sequence, and my rule, because I'm dividing, is going to be, again, 1/2 n, or n over 2. Okay, my last one. So this one, notice again how we're going from a negative to a positive to a negative to a positive. So that means I have to multiply it by a negative number. So let's go ahead and multiply it by -2. -1 times -2 is 2. 2 times -2 is -4. -4 times -2 is 8. 8 times -2 is -16. -16 times 2 is 32. And 32 times -2 is -64. Since I'm multiplying, this is another geometric. And this time, since I'm multiplying, my rule is going to be 2n. Okay, and that is our lesson on arithmetic and geometric sequences.